Okay, so a fast video on finding critical values for confidence intervals. So I got 3 different ones, and we'll have other distributions as we go along, but the idea is going to kind of stay the same. So if I want to, for a Z procedure, a 97% confidence interval, and I want the critical value, if I'm using StatCrunch, I go Stat, Calculator. I can't see it on my screen right now, but I'm going down to normal. Pull this over so we can see it a little bit better. And I'm going to leave this as 0, 1. And all I want is to go between. And I want the area in red centered on this to be 97%. So 0.97. So right now I have 97% in here. Well, if there's 97% in the red, there's a total of 3% unaccounted for, which would be 1.5% in each tail. So the fast way of doing this is just what I did right here. Go between, hit 0.97, get the critical values. I'm actually going to go over here and put those in. And usually you can put plus or minus, or you just put the positive. Okay, that's one way of doing it. The other way of doing it, if I was using a table, I would look up, going backwards, and try and find 0.15%, because there would be 1.5% in each tail, and that would give me 2.17 as well. Okay, so 2 different ways of doing it. You have the more traditional way, you have the faster way, whichever. Here's another one. I want 85% confidence interval. So if I do the between, I'd make that 0.85. Boom. Okay, the other way of thinking about it, there's 85% here. There's a total of 15% left over divided between these tails. So that would be, what, 7.5%? So let me put this down right at the moment, 1.4395. So if I wanted to do it the other way or using the table, I would look up 0.075 going backwards, and there you go. So that's the cutoff. Again, we're taking the positive value, but it represents the negative and the positive. If I'm going to do a T, so for like this one here, Stat, Calculator, you can't see it, but trust me, I'm just going down to where it says T, and very similar looking picture. This time I need degrees of freedom. So if my sample size is 34, my degrees of freedom is 33. I would do the same sort of thing. I want between. I want 95%. Come on. It's fighting me today. There we go. So for this particular case, it'd be 2.0345. Now I want to draw your attention to something here. On a normal distribution for a Z, 95% is 1.96 all day long. But for a T, it's going to change every time I change these values. My degrees of freedom, my sample size, as that changes, these change. And you can see it's actually getting wider as my sample size goes down. This is getting wider. If I wind this up to, let's say 1,000, so I have 1,001 sample, my degrees of freedom is 1,000, but look what happens when I do 0.95. Ooh, gives me right back to around 1.96. So it's very close to normal. So we're going to have other distributions, and this gives you an idea how to attack it. I could have used the same process that I did on the other one by figuring out how much is in the tail and go that route. If you're stuck with a table, that's one way of doing it. So this should give you some options.